Next point is we go into another section of this particular chapter, और ये है thermochemistry. This is called as thermochemistry. As the name suggests, when you talk about thermochemistry, thermo मतलब it is heat. Okay, chemistry. So यहाँ पे we talk about reactions, and specifically we are going to talk about chemical reactions. So how to define this is, it is nothing but a branch of thermodynamics. It is a branch of thermodynamics which deals with the heat changes, or we say the enthalpy changes taking place during a chemical reaction. अब तक हम लोग ने कौन सा रिएक्शन कंसीडर किया था? फिजिकल रिएक्शंस. ओके, अभी हम कौन सा रिएक्शन कंसीडर करेंगे? केमिकल रिएक्शंस. आई बात समझ में? सो केमिकल रिएक्शन में आई ऑलरेडी टोल्ड यू दैट देयर हैज टू बी अ चेंज इन द केमिकल कंपोजिशन. ऑलराइट, सो लेट अस स्टार्ट ऑफ विथ, ओके, लेट अस कंसीडर A moles of A reacts with B moles of B to give you C moles of C and D moles of D. ये जो small a, b, c, d है, those are the coefficients of the reactants as well as products. उसको number of moles भी बोला जाता है, और उसकी वैल्यू तभी हमें मिलेगी जब हम रिएक्शन को बैलेंस करेंगे. इसलिए दोस्तों, in the beginning part only, when I'm going to start with chemical reactions, the first and the important condition, please don't forget, my dear friends, and that is whenever you need to proceed, first always proceed with balancing of the reaction. Okay, physical reactions में balancing का part नहीं आया था, लेकिन यहाँ पर balance करना बहुत जरूरी है. Okay, तो ये बात याद रखिएगा. Now, if you want the enthalpy of a reaction, okay, this is called as what? Enthalpy of a reaction. I also give it a symbol as delta RH. So how to define this is? Okay, उसका पहले मैं आपको एक formula दे देता हूँ. The formula is delta RH, that is enthalpy of the reaction, is equal to nothing but C into HC plus D into HD minus of A into HA plus B into HB. This is what it is. Alright? Now, HA, HB, HC and HD are the enthalpies of the respective reactants as well as products. समझ में आया आप लोग को? Okay, and therefore we can also say delta RH is equal to, ये प्लस साइन है मतलब समेशन है. एंथैल्पी किसका है? ये प्रोडक्ट्स का है. सो एंथैल्पी ऑफ द प्रोडक्ट्स माइनस समेशन ऑफ एंथैल्पी ऑफ द रिएक्टेंट्स. ओके, ये हमें फॉर्मूला मिल जाएगा, और इसी फॉर्मूला के आधार पर अभी हम स्टेटमेंट लिखेंगे, एंड दैट इज, शुरुआत कहां से करेंगे? ये देखो, ये माइनस है. माइनस है, दैट मींस व्हाट इट इज? द डिफरेंस बिटवीन, ये कौन सा सिंबल है? समेशन का है. सो बिटवीन द समेशन ऑफ एंथैल्पीज ऑफ द प्रोडक्ट्स एंड दैट ऑफ the reactants, when all the substances are in their specified PS, समझ में आया होगा? फिजिकल स्टेट. ये सब के एक पर्टिकुलर फिजिकल स्टेट होंगे, either solid, liquid or gas, in a amount which is given by the coefficient of a balanced chemical equation. इसका जो अमाउंट है, उसका जो प्रपोर्शन है, वो किससे दिया जाए? बाय मीन्स ऑफ कोएफिशिएंट. कौन सा कोएफिशिएंट है यहाँ पे, ये देखिए, ये जो स्मॉल लेटर्स वाले हैं ए बी सी डी, ओके, दोस आर द कोएफिशिएंट, और वो कभी कभी मिलेंगे हमें जब हम रिएक्शन को क्या करेंगे, बैलेंस करेंगे. Okay, so once again I repeat the definition. It is nothing but, which definition am I talking about? Yes, it's the enthalpy of a reaction. शुरुआत यहाँ से करनी है. So it is the difference between what? The summation of enthalpies of the product and that of the enthalpy of the reactants when every substance is in the specified physical state. यानी फिजिकल स्टेट हर एक सब्सटेंस का लिखना जरूरी है, फिर चाहे वो रिएक्टेंट्स हो या प्रोडक्ट्स हो, in an amount, okay, or in a proportion which is given by what? The coefficient. How you get the coefficient? By means of a balanced chemical equation. बोला, समझ में आई आप लोग को? Everyone, very good, very good. Next one is, इसी के आधार पर we can talk about the exothermic and the endothermic reactions. When you talk about an exothermic reaction, you know exothermic reaction is nothing but what? Negative. So delta RH is negative. And therefore what we say is that the enthalpy of the products is going to be less than the enthalpy of the reactants. ये formula है दोस्तों, products minus reactants. So the products कम है reactants है, so lesser minus higher value will be always negative. उसी तरीके से दोस्तों, when I talk about an endothermic reaction, इसका ऑपोजिट कर दीजिए. सो डेल्टा आर एच इज इक्वल टू पॉजिटिव, और वो उसके लिए क्या बोलेंगे, एच पी शुड बी ग्रेटर देन एच आर. ओके, एच पी ग्रेटर देन एच आर, हायर माइनस लोअर विल बी ऑलवेज पॉजिटिव, एंड पॉजिटिव है, सो दैट मीन्स इट इज एंडोथर्मिक. और इसी से हम लोग एक और इंफॉर्मेशन पता करेंगे, दैट इज, यहाँ पर मैंने क्या बोला, एंथैल्पी ऑफ द प्रोडक्ट्स इज लेस. एंथैल्पी मतलब इट इज हीट, हीट इज अ फॉर्म ऑफ एनर्जी, सो प्रोडक्ट का एनर्जी कम है, और अगर एनर्जी कम है तो ऑब्वियसली उसका स्टेबिलिटी ज्यादा है. सो एक्सोथर्मिक में क्या बोलेंगे, द प्रोडक्ट्स आर मोर स्टेबल. ओके, इन एंडोथर्मिक रिएक्शन में हम क्या बोलेंगे, किसका एनर्जी कम है, रिएक्टेंट का. अब रिएक्टेंट का एनर्जी कम है तो उसका स्टेबिलिटी ज्यादा है, सो रिएक्टेंट्स आर मोर स्टेबल. ओके, तो दिस इज वन मोर इंफॉर्मेशन दैट वी गेट. सो वंस अगेन आई रिपीट, in a exothermic reaction, okay, यहाँ पर मैं लिख के रखता हूँ, in exo products are more stable, and in endo the reactants are more stable. आई बात समझ में दोस्तों, ये बात absolutely clear, everyone? Yes, thank you. Once you have understood about what exactly is endothermic and exothermic reactions, now I'll give you some examples so it becomes very clear to you. The example is, we have a combination of nitrogen as well as oxygen, both reacting with each other. It can be an atmospheric reaction as well, because nitrogen and oxygen both are present in the atmosphere and they form the major constituent of air, and you know this very well. So N2 plus O2 gives you NO. Now the enthalpy of this particular reaction is plus 66.4 kilojoules per mole. Now this is in the gaseous state, this is in the gaseous state, this is also in the gaseous state. Now you balance the reaction, so it gives you 2NO. Now because the sign is positive, so that means it has to be what? Endothermic. Right? The same way, if I give you an example of KClO3, okay, it's a solid state. It undergoes decomposition, it is going to give you KCl as well as O2. Alright? If you balance the reaction, so this is what we get. And enthalpy of this particular reaction is going to be around minus 78.4 kilojoules per mole. So it's negative. And negative means it is going to be a exothermic reaction. Alright? So depending upon the signs of the enthalpy of the reaction, accordingly it is easy to comment whether the reaction is endothermic or whether the reaction is exothermic. And accordingly it is also easy to comment whether the energy has to be absorbed for this reaction to take place, or due to this reaction the energy is released. Am I very clear? The concept is clear up to now? Alright. Now we go into another part, and that is, according to thermodynamics, what do you mean by a concept called as standard state. All right, thermodynamic standard state. Now, my dear friends, when you talk about thermodynamic standard state, standard means what? Something which is going to be known. So, we are talking about a state where the substance is going to be stable under the known conditions. And what are those known conditions? Pressure is equal to 1 bar, temperature is equal to 298 Kelvin, and if I'm talking about a substance to be in the form of a solution, then the concentration has to be 1 molar. Alright? So these are the conditions that has to be kept in mind. Okay, so these are known conditions, and that's why, because it is known, that we call it as what? Standard state. Alright? So whenever a substance is going to be stable under these particular conditions, then we say that yes, they are going to be in the standard state. Okay, so that means we talk about H2 and F2 and Cl2 and C and all these. Okay, so they are considered to be in the standard state. Now, whenever it is in a standard state, so remember one thing is that we are going to use a symbol, and that is not. So accordingly, if I'm going to talk about the standard enthalpy of a reaction, enthalpy of a reaction, you know very well, it is denoted as delta RH. Now I'm going to use a symbol that is not. So now this becomes the standard enthalpy of a reaction, where it is nothing but it is the change in the enthalpy of a reaction. It is the change in the enthalpy of a reaction where all the reactants as well as the products are in their standard state. And what is a standard state? I've already told you. Alright, so this is what is the difference between the enthalpy of a reaction and the standard enthalpy of a reaction. If you remember, when I've defined you the enthalpy of the reaction, I told you that the reactants and the products has to be in a specified physical state. Now that is to be now replaced by what? The standard state. Otherwise the formula remains the same. The formula will be now standing as summation of delta R H naught, that is the standard enthalpy of a reaction, for the products minus of H naught of the reactants. Alright, that is what we are going to write down, or simply we just write down this way also, it is easier. H naught products minus H naught reactants, so that is going to give you nothing but delta H naught R. So this becomes your formula. Only thing is we are going to use a not. That's it. So instead of a standard physical state, we are now going to use simply that is standard state. Okay. So I hope you have understood up to this. The two examples to make it very clear what is endothermic as well as exothermic, and then what do you mean by a standard state. Okay. So I guess this part is very clear to everyone. Yes. All right.